I'm Ben Wylie, president of Wylie Engineering. So we're a mechanical, electrical, plumbing consulting engineer in Houston. We have had the. Oh, okay. All right. Well, I've had the pleasure of working on this building, several others with Skanska, and with Marie and Gensler. So I feel like my topic is going to be, I'm not sure, a bit, not as, maybe as a little bit more boring, but we are challenged with this AIA 2030. And so I thought by you opening up with AIA 2030, which is a very, very challenging goal, a lot of that is challenge to MEP engineers because we design the systems that consume all the energy in these buildings. So my topic is on reducing, very specifically, fan energy in HVAC systems, which is a major consumer of energy, and it's really one of the last. We've kind of tackled all the low-hanging fruit. So with that, I guess I'll dive in and talk about one technology that we have recently implemented. This is something that we've put onto Skanska's 1550 on the green. These are what are called ECM motors, or electrically commutated motors. I think my title at the top got messed up, but these are brushless DC motors. They don't take a variable speed drive to ramp up and down. Variable speed drives have all these inherent electrical losses. These motors have been around for maybe 2 decades, but in fractional horsepower, like in the fan-powered boxes that are above the ceiling. In the past maybe 5 years, they've scaled up to full air handling unit systems, big motors. So the fan arrays there are, examples of a big built-up system. On the project at 1550 on the green, we have these fan arrays with a total of about 6.5 brake horsepower total, versus in a traditional system, even a very, very efficient system like this building would have been about 10. So this is technology that's fairly new and being applied to reduce the fan energy. The next example that I wanted to take, this is an example of how to really eliminate some of the fan energy, which is about 40% of the total consumption in a commercial office HVAC system. This is an example of a chill beam system. So rather than transport air, which is like a very energy intense process, water is much more efficient. We can move to cool this room 10 tons. It would take a 24-inch diameter duct. We can move the same BTUs into 2-inch pipe. So we have applied this into a project in Houston. It's being applied at U of H. It's in a project at, I know, Exxon, high sensible spaces like labs. You can move water way less energy out to the space, directly to the space. You still move some air, so these beams take a supply of air, generally 100% fresh air. It's a very indoor, environmentally like IAQ positive space. It takes about 70% of the fan energy just out of the system altogether. So these are ways that we kind of look to really drastically impact the energy consumption. And the last example I wanted to throw out was really eliminating fans from a major consumer of energy, which is a data center. So traditionally, data centers are 100% forced air systems, hot, cold aisles, raised floor. Servers pull air off of the heat sinks, blow it out the side of the back of them. That air is all brought back up, sent outside the building, rejected. This technology actually has the servers immersed in a mineral oil. It's kind of like a baby oil. They're sitting in a bath, and no air moves through the whole facility. It's quiet. All of that energy comes back out through that oil back to another water system, goes out of the building to like a chiller or a dry cooler. We're seeing like POEs of 1 versus 1.5. It's a drastic reduction, which will be a huge trend as like AI picks up and has this massive computing need and cloud computing and so forth. So those are my